Hello, ladies and gentlemen, Mrs. Hamby here, and today we're going to talk about dilations. And we have done a little bit of dilations, but now we're formally actually going to discuss it. We just did it in a Delta Math assignment real quick. All right, so what are dilations and scale factors? That's our essential question, and how do we identify them? I can test the properties of dilation on a given figure. I can generate the scale factor. All right, here we go. And so a dilation is a non-rigid transformation that changes the size of a figure but not its shape. So we've talked a lot about rigid transformations. And rigid transformations are those things that it preserves the size and the shape. They're going to be the same. So if we have two figures, the size is going to be the same, the shape is going to be the same. That would be a rigid transformation. So that was like your reflections, your translations, and your rotations. Okay. And feel free to go ahead and pause this video whenever you need to. That way you can fill out your notes either on paper, or you can use the Google Doc, or you can use the PDF and use Kami. So be sure to pause this whenever you need to, and to write this stuff down in your notes. Okay, so what we're talking about is a non-rigid transformation. So that means it's going to change the size. So it's going to be the same shape. So you're going to start with a triangle and it's going to look like the same shape. The only difference is that it's going to be a bigger size. So it's either going to blow it up or shrink it. So it's going to make it bigger or smaller. All right, the center of dilation is a fixed reference point for the reducing/enlarging a figure. So that's what we're talking about. We're going to take a figure or a shape and we're going to make it smaller by reducing it, or we're going to make it larger or bigger. So think of a copy machine and shrinking it, or blowing it up and making it bigger. All right, scale factor. When we use the letter K to represent the scale factor, it's a ratio of side lengths for the image to the pre-image. And remember that word ratio. Ratio is just a fancy name for a fraction. And here's what's really important. So make sure you write this in your notes. We know the K is always going to be the image over the pre-image. So remember, the pre-image would be just your A, and then the image would be your A prime. So it would be your what you start with, and then on the top would be your copy, like how did you change it. And just so you know about the scale factor, hopefully you learned in your exploration, if your scale factor, your K, is 1, it's not going to change in the shape. Where hopefully you realize if the K is bigger than 1, let's use the greater than symbol. If your K is bigger than 1, then it's going to be larger. It's going to blow it up. If your K is less than 1, so that would be fractions like a half or a fourth, then it's going to shrink it. Okay, so if your scale factor is a number larger than 1, it's going to make it big and blow it up. If your scale factor is a fraction smaller than 1, then it's going to make it smaller and shrink. All right, here we go. Now we're going to talk about the properties of dilation. So in order to prove it has a non-rigid transformation or a dilation, you need to make sure it has these 3 properties. And so the first property is going to be preserves, or it keeps something. So obviously, before when we did rigid transformations, it changed. This is going to change size. So before, the size would stay the same. Now what we're going to do is we're going to change the size of the shape. And here's what's going to keep. Here's what's going to stay the same about your figures. Angle measures. So all the angles are going to measure the same. So if you had angle A is 50 degrees, then angle A prime is going to be 50 degrees. Collinearity. So if you didn't know what that word means, all that means is it's going to be points on the same line. So if we have a figure and we have A and B on the same line or segment, then when we do our dilation, then A prime and B prime have to be on that same line, okay? And then orientation is basically it's going the same direction. So we're talking about direction. So the shape better not be a reflection where it's mirrored over something. It should be the exact same direction. All right, so this will make more sense when we do an example. So here we go. All right, this is in your textbook if you were wondering. It's example on page 579, but you can just use the notes I provided for you, or if you want and you grabbed your textbook, you can get this example from there. All right, determine if the transformation is a dilation. If so, give its scale factor. All right, so we must preserve angle measures. And so if we were in class, I would give you guys protractors. And remember, we're going to go look at the pre-image, and that's the one with the A. So this is the pre-image. And then the A prime is going to be the image. So here's where you start with, and then you did something to it, and this is our new image. All right, so if we were in school, I would give you guys protractors, and you guys would actually measure those angles to make sure they're the same size or they're the same measure. But we're not in school, so you can just kind of take my word for it. You can also kind of tell that A does look the same as this angle. Same thing with D. D looks exactly the same as this angle, and C and D, and they look to be the exact same measure. So we're just going to say yes. You have to kind of take my word for it because we can actually physically measure these right now. But if you want to, if you have a protractor, you can go ahead, take your protractor and measure those angles. All right, preserves collinearity. So basically that says, okay, if we're starting with A and D, then, and they're on the same line, then A prime and D prime have to be on that same line segment. And same thing here, D and C are on the same line, so D and C are on the same line. All right, and then so yes, it preserves collinearity. And then you could do the same thing, B and C are on the same line. Now, preserves orientation. Remember, orientation is the direction. So if you notice, from here to here, it does not preserve orientation. And the reason for that is you would have to have this shape, and if you just like moved it over here, then A would have to be here. So it would have to have that same kind of shape over here. And you can tell that it's not. It's like flipped over. It looks like it's flipped over the y-axis. And so it does not preserve orientation because this was not in the right position. The shape's not the same size. I mean, it's the same size, but it's not going in the same direction or orientation. All right, so since this one failed, since the orientation is not preserved, then is it a dilation? No. And since it's not a dilation, you can't state the scale factor. Okay, so hopefully you see that, that it has to have all three of these things in order for it to be a dilation. All right, so let's do another example. Determine if the transformation is a dilation. If so, give it scale factor. Preserve angle measures. Okay, kind of hard to see, but it does look like C and C prime are about the same degrees. Same as B and B prime. They look about the same degrees, so we're going to say yes. Preserves collinearity? Yes, because A and B are on the same line, and so is A prime, B prime are on the same line. And same thing with B to C. B and C are on the same line, and B prime, C prime are on the same line. So yes, it preserves collinearity. Orientation or direction. Yes, you can kind of totally see that the C and C prime are basically the same orientation. It's just basically blown up. It looks like that triangle is the same triangle, same shape. It's just a bigger version of it. Okay. So does it preserve orientation? Yes. We don't have anything that's like flipped over or anything. All right, so since all three of these things are true, they have the same angle measure, the sides are in the same line, and the triangle is going in the same direction, it's basically the same shape, then it is a dilation. So yes, it is a dilation. And if it's a dilation, then you got to state the scale factor. And so before we stated that the scale factor is always the image. So we got to find K. It's always the image over the pre-image. And what we mean by that is if we were given the length of this, we would go, okay, we're going to start with the length of this side divided by the length of this side. But since we don't know that the length of any of these sides, we're going to have to use a different method. And I like to look at the coordinates. So I'm just going to take this coordinate right here, which is coordinate A. So we're going to start with our A. And I'm going to give you that it is -2, -2. And then if we get the coordinates of A prime, so remember this is your pre-image, and we're going to our image, then you can see that this is going to be -4, -4. And you could do that with all of our points. We can go from A to A prime. We can even go B to B prime. Maybe I'll do it with B as well. So the coordinates of B is going to be 1, -1, and B prime is going to be 2, -2. So hopefully you guys can see that. It went right down to -2. And hopefully you can see what is going on here. If we're going from -1 on our x to -4 and -2 to -4, what is it blowing it up by? So we're basically taking all of these things and we're timesing it by 2. So our scale factor for this is going to be 2 because we take that middle triangle and we're basically blowing it up twice as big. All right, so let's do a couple more examples. Determine if the transformation is a dilation. Explain how you know. All right, so remember our properties. We have to first state whether or not the angle measures are the same. I don't know about you, but it looks like all of our angle measures look to be the same. And then collinearity, yes, C and B are on the same line as this C and B prime. And then orientation. Look at D is pointing this way, so is that one. So it does preserve all three of those properties. So we're going to say yes. Oh, geez. So yes, it is a dilation because it has all, instead of it has, it because it preserves the properties. Remember, the angle measures are the same. The segments have collinearity, and it preserves orientation. And then let's go ahead and talk about the scale factor. This one would be really easy. You can look at the coordinates like we did last time, but it'll be even easier to go ahead and look at the actual side lengths. And so if you notice here, C to D, it's pretty easy to see how big that is. Or you could even go D to E. But if you notice, if you go from D to E prime, it's kind of hard to tell because it's not perfectly aligned. So I really wouldn't want to use D to E prime or D prime to E prime. I would want to use C to D. And if we use C to D, we notice this length is 2 and this length is 3. And remember, you always do the image. I don't know why this thing keeps messing with me today. Image. All right, so we're always going to do our image. So the image was the C prime O D prime, so it's going to be 3 over our pre-image, which is 2. So this has a scale factor of 3 over 2. All right, so now we're going to go ahead and we're going to look at this one. The angles, they look about the same. So B looks like the same as the angle B prime, which is a 90-degree angle. A looks like the same. All right, collinearity, yes, A, C, and then A prime, C prime are on the same line. But orientation, it's obvious that this thing is flipped over. And so this one is not a dilation. Because it has a different orientation. So hopefully you understand what I'm talking about with the orientation. So look at here, C is pointing down, where here C is pointing up. And so we can't do that. It's like a reflection over the x-axis of it. All right, one last final example, and then we are done. Here, let me go ahead and do the lines. So how do we determine if the this is not the right direction. All right, hopefully you noticed I changed the directions because I had the wrong directions. All right, so this is the same as that previous one where we had the scale factor of 3 over 2. And so we want to figure out the center of dilation. And this is really nice and easy. Basically, all you do is wherever you have the image and pre-image points, so E prime, what you're going to do is you're going to draw a line through them. And you're going to do that for all of your points, your vertices. And so if you notice, we have it going through there, and then we go through D and D prime, and then we're going to go through B and B prime, and you'll notice that's just a vertical line going up and down. And then C prime, A prime, they're on the x-axis, so it's a horizontal line. And so you can see when you line up all of those, you put a line through the image and pre-image and image vertices, then they show you exactly where the center of dilation is. So it's going to be obviously right here at the origin, which is 0, 0. So all you have to do is draw lines through all of those letters, and wherever they all intersect, that is your center of dilation. All right, hopefully this helps. Be sure to take your notes and upload it to Google Classroom. If you need help with it, please let me know.